In this presentation, each of the images that we'll see have in the lower right the source and in fact the satellite name from which the image was captured. On the left is looks like a fishbone or a railroad track. Each time one clicks one notch higher towards the top, the resolution or the magnification essentially of the image increases. And so we will do this zoom to Hawaii, the emperor chain, and coming up in the middle of the screen as we talk is the big island of Hawaii, with the ocean floor all around it, of course, shown in blue. The big island of the emperor chain, of course, is Hawaii. And as we zoom in closer, we see some of the towns like Hilo and Kona, at least known to the tourist world. And as we zoom still closer to the island, as we come to the southern shore, we see the area of the Volcanoes National Park. The black is recent lava flows, the green is still vegetation, and the ocean is, of course, showing in black as we zoom in close. The clouds look like popcorn, but amongst the clouds is this long vent that we've just identified as the gas plume of the Kilauea Pu'u'o'o vent. It will be kind of an orienting feature in many of the images in the next few moments. Notice it in the upper left with the wind pushing it down to the lower left. And the black lava flows issuing from Pu'u'o'o and perhaps other craters more historically have fallen down topography and come to the ocean, sometimes leaving green islands of material called kapukas in the black lava flows. Also, in some of the images, again Pu'u'o'o for orientation, there are older craters, the chain of craters road, and now we've changed the position around a little bit and scan back and forth, not saying over Pu'u'o'o necessarily, but following its vapor trail down to the lower left and seeing at a higher resolution, more magnification image, the resolution of some of the very recent, the more black, the more recent, the more brown and gray, the more weathered, the older the lava flow. And so if we put together what we've seen in a montage in the upper left, however, do note, just said next image, on the lower right, we will zoom up in magnification to that image, again Pu'u'o'o. Now, interestingly enough, we take the USGS map by Christine Haliker, many years of field work. Let's look again at the satellite image, let's look again at Christine's map, and through the magic of television, we have superimposed them, and it's amazing, really amazing, to see how accurate Pu'u'o'o is in the same place on both images. The shoreline is just totally coincident, and Christine has colorized the more recent flows, each color meaning a different period of eruption out of Pu'u'o'o. Again, let's see this just in repeat. In Lesson 7, we in fact do have a section on the utility of satellite imagery in geologic work, particularly on volcanoes. And it's very interesting to see that years of field stomping to get accurate maps can be done from the comfort of an armchair with the right satellite photograph, and then perhaps to do good science one would go out and do ground truth in the field to be sure that the material is accurate from the satellite with ground truth. By way of review at the end of the zooming of satellite pictures, let's replay the zoom from the west coast of the United States into Hawaii with the fairly high rate of image zoom refreshment. This whole lesson, Lesson 6, is the origin of Hawaii, and we've taken a zoom trip to look at some of the volcanic features by way of review, and as we close our thinking on the origin of Hawaii, realize the pictures that we're seeing, compliments of Don Swanson at HVO, give us the idea that volcanic replenishment of the island, in fact the creation of Hawaii, was entirely volcanic, as the lavas pour into the ocean and build up and become new islands such as Loihi, now happening off the coast of Hawaii. Lava is destructive, but lava is also constructive in the building of the Hawaiian emperor chain. So aloha from Hawaii.